Okay. All right. When you go into Hawks next time, you'll notice there's another assignment there. It's the chapter 1 through 4 test review. So it is, you do not have to complete it. However, it is probably in your best interest to do it a couple times. Basically, it's an exact duplicate of what the actual test is going to be that you can practice with. Okay? Because your test isn't next week, it's the week after that, though. So, and with Monday's class being, we're not having class on Monday because it's President's Day and the college is closed. It's only a couple days before your actual test anyway. So we will, it's there. You can do it as many times as you want. It will not give you your score until you're done with the test. So you'd have to do all the questions to get your score. Or what I would suggest doing, because you can do it as many times as you want, the first time you go in to take the test, just submit it and don't answer a single question. Then you'll see the answers to every single question and you'll understand how they want you to do it. And then go back and do the test again. When you take your actual test in class, you are allowed an index card, 3x5 or 4x6. So what my suggestion would be is while you're going through and doing the practice test, if you need to look things up, write that down in your index card. This way you don't have to look it up in class. Yep, you can use both sides. It just has to be handwritten. You can't have nothing typed or stick to it or stapled or anything else like that. So, any questions on that stuff? We will do a review of the test in class that Monday before the test. So I'll be able to go over any questions and stuff you have on the test. Yeah.
What's the date?
Hold on. It is the 26th. All right, so chapter 3, we looked at graphing. We looked at some different picture graphs and stuff like that. And we started doing some calculations in the last class. This chapter is going to be a lot more calculations. So here are two. What are those? Those are histograms because they're connected. And I erased the numbers on the bottom on purpose. All right, so going based on these two charts, what are some things you can come up with? What are some patterns or information or your thoughts on what the actual waiting times are? Yes.
Is it bimodal on the left?
Kinda. So we're going to talk about mode today. Mode technically has to be exactly the same, but yeah, you could kind of see how there'd be the two peaks there. Where would you want to go? The doctor's office or the emergency room based on these graphs? Because these are showing your waiting times, right? Why?
Because the shortest waiting time has the most, that's like a larger value than the emergency room.
Okay. But then the upper ones tend to be higher than the emergency room too, right? So, all right. So when you're looking at pictures or graphs, they only give you so much information. So we need to start looking at other pieces of information as well. Let's see. When I add the numbers in there, it makes a drastically different impression. So when we're looking at this type of stuff, the information and the data is very important. So we want to look at some pieces of information and pieces of data that we can collect and do some calculations on to give you a value that you can say, okay, this is a way that people are going to understand what I'm talking about. Again, all the stuff that we're looking at, except for one thing, which I'll specifically tell you afterwards, these are all going to be on quantitative data. So we need actual data that we can do calculations on. So the vast majority of the stuff we're going to talk about today is not going to be on qualitative data, just quantitative data. All right, so some of the things that we might want to look at when we're looking at data. Location. Now, I'm not talking about Norwich. We're talking about where the center of the data is. So now remember back to your elementary, middle school, and maybe high school. Normally this is taught in middle school. What were some of the ways that we could figure out where the center of the data is?
Median.
Median is one of them. What's median?
The exact middle data point.
Okay, so that's the exact middle data point. Okay, what's another one? Yeah. Modes. What's mode?
Or missing it.
One of them is average, but not mode. Think about what bimodal meant.
Oh, it's the two highest points.
It's the highest points, right? So mode's the one that appears most often. That's actually the only one that we can do on qualitative data, because you can say, I have the most names of Tony, for example. You can use words for that. All right, what's the other one? There's one more. Yes, mean, which you probably know as average. So mean is the average, okay? Is average also the center of the data? Okay, why?
Because you can have outliers, say like, that are way beyond the middle, I guess, or way under.
Yeah. So mean has a tendency to get skewed, as we call it. Where median is typically right in the center, mean can be pulled based on either really low values or really high values. So let's pull it up. I don't think I have it on the slide. Nope. So we're looking at these poverty rates ranged from a low to a high. So we have range that we can look at. We're just talking about median. So median household incomes. That's how they use median price. So you'll typically will see whenever you're talking about wages and housing and anything like that, you will always see them use median instead of mean or average. Because let's just take the state of Connecticut, for example. I'm going to suspect most of you live around over here. So I'm just going to throw average home price over here, $250,000, $300,000. It's probably higher than that. Honestly, I haven't looked, but we'll go with that. Is there other parts in the state that those average prices are the same? Yeah. Are there places in the state where the average price is a lot higher? Yeah, things like Fairfield County, Greenwich, and stuff like that. The average home price is $1.5, $2 million. So if I looked at an average, those housing prices will pull the average price of in the state of Connecticut way higher. So to get a general overview of what's going on, the median gives us a better view of that. If you thought of Hartford, would you think there's very, very wealthy homes in Hartford? In general.
I mean, it's the city, isn't it? Maybe.
It's a city, but it'd be like New London. If New London also had Waterford, which it should, because Waterford completely surrounds New London. But so in Hartford, the majority of the area is considered urban and lower income. However, the governor's mansion's in Hartford. And the area over by the governor's mansion, the homes are $1, $2, $3, $4 million homes in Hartford. You wouldn't think that, but they're there. And so that if we looked at the average, that one house is worth 40 times what some of the other houses in Hartford are. So that would skew the results. Now, let's think about how we'd want to use that. Remember we said those numbers are both accurate. Average, median, both average, both completely acceptable terms. If I wanted to show that Hartford was a a well-off area and things like that, I might use average for my home prices because I'm going to use that to pull up some of the other ones. Okay. If I want to show that it's not, maybe median is going to be used. So you can start to see how people can use the same things in different ways to get you to view the information a little bit differently. And both of them are completely and utterly accurate. They're not lying. That information is exactly true. However, when the general public doesn't really understand what those terms mean, they just assume they're the same. Most people, if you ask, is median and mean the same? They're going to tell you, yeah. They're going to tell you they're the exact center. Okay, because that's what people think of as average. It's the center. So that's where we can start to look at those types of things. The next thing we're going to talk about today is what's known as dispersion. Dispersion is how spread the data is. Okay, so if we have a bunch of data that's really, really close together, that's one thing. Although if we have a bunch of data that's spread way out, that's another thing. So we want to look at how it's spread. We're also going to look at, we kind of looked at this briefly in the last class, where is it symmetric? Is it skewed to the left, skewed to the right? And I'm actually going to show you exactly why that's the case today. All right, let's look at a couple terms. We've talked about these before, but let's refresh our memory on them. We have descriptive statistics and inferential statistics. The difference between those two, let me swap these. We'll talk about that in a minute. Descriptive statistics is telling me what the data is showing. Okay, so mean, mode, median, all descriptive statistics. Standard deviation, descriptive statistic. The next step that we can use is if we take those descriptive statistics and we use that to infer something about the general population. That's inferential statistics. That's the big difference between those two. Okay. So most of the time you collect data, you get the descriptive statistics, you find those numbers, and then, okay, we got this numbers, what do we do with it? That's when we infer things. That's when we make that generalization, and that's the inferential statistics. Parameter and statistic we talked about before. Parameter goes with population. That's the entire population that we're looking at. Statistic goes with the sample. That would be the groups that we're looking at, the smaller groups that we're then going to use to infer something about the entire population. And the letters kind of make sense. Parameter, population, statistics, sample, PP, SS, so it works out well. All right. Any major questions about those terms? Okay. Now let's start doing some work. All right. Find me the mean of these numbers. How do I find mean or average? Same concept. Yes. Yeah, good. Yeah.
The sum of all the samples divided. Wait.
You're making it harder than
Yeah.
it is.
The sum of the values divided by how many values?
Yeah. Add them all up, divide by how many you have. All right. So add those up and divide. Yes. Just because I want to show you the crazy symbols and everything else they use to do this. All right. I am not going to expect you to use these symbols when you write things out and everything else, okay? However, you are going to see them, so kind of knowing what they mean can be helpful. The first one is probably the most important one, is that. that symbol right there means the mean. Okay. The X with the bar over it. That means mean. So when you see that, they're looking for the mean. This crazy E symbol, that's known as summation. All that means is we're adding them all up. Okay. It's actually epsilon. Remember it? Where is it? Sigma. Hold on. No, that's not. I can't remember the Greek letter.
Wait, what did he? Oh,
Sigma. Okay. E got stuck in my head. That's why I was thinking epsilon. That's Sigma, which makes more sense. I got to get better at my Greek letters from going there this summer. All right, so that's summation. So those are the two symbols that you're going to see a lot. Again, you don't need to use them. If you see that, you're just adding a bunch of things together. The X with the bar over it, though, you will see that symbol a lot. That means mean. I'm going to go out on a limb and go, nobody really has trouble finding mean or average. Okay. However, this is statistics class, and I got to make everything harder than it has to be. So there's a bunch of other means that we get to talk about. The first one is known as a weighted mean. This is actually one that's really important if you ever want to figure out your GPA, because your GPA is based on a weighted mean. All right. So we've got, let's see. So in a weighted mean, the number that we're going to multiply or add, we actually have to do some calculations on it. So what is the GPA for a B? All right, let's make the easy one. What's an A? 4. B is one letter down, so it would be A, 3, and C is A, 2. Okay. Since we can't use letters, we need it as numbers. Remember, I can't do this in qualitative data. I need quantitative data. So we have to have it in terms of a number. That's why your GPA is typically calculated as a number. All right. So we've got the grade in terms of an actual number, and we've got the credit hours. To do a weighted mean, we have to do the multiplication first. So technically, when you're doing a GPA, it's the number of credit hours weights your grade. So the more credits, the higher that's worth in your GPA. So for this one, I have 3 B's in essence. So what's 3 times 3? 9. I have 4 4s. So I multiply that, I get 16. I have 5 2s, because I have 5 C's in essence. What's 5 times 2? And then 4 times 3 is 12. We then add all those together. 47. Is that my mean? What do I got to do? What do I always have to do at the end of mean? I have to divide it. What am I dividing it by? 4? So if I divide it by 4, what do you get? Yeah.
Divided by all of the numbers in the grade bump.
Okay. We'll do yours in a second. We'll do yours in a second. What's 47 divided by 4? 11 and change, actually. 11.75. Does that make sense for your GPA? No. Okay. So one of the things, and this actually is a very important skill that a lot of people don't have, especially in math, is you do something, you get an answer, you move on. Ask yourself that question. Does this make sense? Okay. 11.75 does not make any sense for a GPA. So, all right, we've done something wrong. Don't just move on. Figure out what you did wrong. and I don't know your name off the top of my head, but you said the correct way. We need to figure out what we're dividing it by. Remember, I added, this is 3 B's, 4 A's, 5 C's, and 3 A's. So I actually have to add these up to figure out what I'm going to divide by. So 6, so that's 15. So I'm not dividing by 4. I'm dividing by 15. Which comes out to be 3 point something. Let me get the actual number. 3.13. Does that make sense for a GPA? Yes. Okay, so that's what you, when you're looking at a weighted mean, that total that we're dividing by is the total of whatever pieces I have. Really, the only reason it's a weighted mean is it gives me the ability to combine the numbers together ahead of time. So I don't have to write down B, 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 A, like all those things out and write it. I'm combining them down. So that's what your weighted means are. You use it in GPAs. You use it to calculate your grade in any class that you're taking. Your teacher gives you the syllabus at the beginning of the year, and it says your tests are worth this percent, 45%, your homework's worth 20%, so on and so forth. That is a weighted grade because you're going to take your grade in each of those categories, multiply it by what the percent was, and then in that case, you're dividing by 100, and that's how you get your actual answer. So you do those calculations out that same way. Okay. Those are weighted means. So you've done this actually before and probably didn't even know it had a name, which is just done. Okay. Does that make sense? Okay. Next one. One of the things that got mentioned when we're looking at average, or when we're talking about mean, is that outliers can change that. Okay, so if we have an outlier, it really pulls that information one direction. So if you looked at this set of numbers right here, 16, 18, 20, 21, 23, 24, 26, 32, 36, and 490, if I took the mean of those, you'd get 70.3. Is that a good estimation of that information, of that data? Does that give you a good call? You said, yep, that's good. It makes total sense, 70. No. Okay, but is that the correct mean? Yeah. So in this set of data, we might want to look at median and other ways to do it. However, there is a way to do it with a mean. It's known as a trimmed mean. Basically, what that does is it cuts off terms on either end to eliminate those outliers. So we can have a little bit better of an understanding of what's going on in the actual data. So how many values are here? 10? Okay. So it's 10% of 10. 1. So we're going to cut off one number on either end. So we're going to eliminate the 490 and we're going to eliminate the 16. So when you do a 10% trimmed mean, you eliminate 10% from both sides. Okay, so in this case, we're eliminating 1 from both sides. If I wanted a 20% trim mean, I'd have eliminated 2 from both sides of this data because I had 10 numbers. Okay, all right, find me the mean of those numbers. What do we got for our mean? When you add them all, yeah. Let's see, did I add them up right? I'll go with that.
Yeah.
No, you're possibly right. I got 24.62. 5. 18, 20, 21, 23. Okay, I just wanted to make sure I actually add them correctly. That's why I was asking to verify that I actually add mine correctly. Yeah. So 24.625 is what I ended up getting. So it's 197 divided by 8. I did the actual calculation. So is that a better representation of the data that's there? Yeah, that sounds about right. Maybe on a little higher end because 32 and 36 may be a little bit bigger than the 18 and the 20s there. But generally, if you look at the rest of the data, that's a reasonable number to expect. It's a lot better than the 70.3. All right. Okay, so those are the 3 different means we can have. Notice they're all basically the same thing. The key piece to them is when you're looking at the data, how do we want to manipulate it to get the number that I want? Okay, yes.
It might be a confusing question, but when they give us like a calculation for a trim mean, will it only be numbers in sets of 10? Like,
Yeah.
oh god, that gets confusing because what if it's like 12 numbers and they want a 10% mean? That's like 1.2. How do you take 1.2?
You're taking 1 off each side. You round it to the nearest number.
Okay.
Yeah, you just round it to the nearest number. But that was a good question. That actually can happen. So yeah, you'd round correctly. So if it was 15, for example, 10% would be 1.5. I would take 2 off each side. So I think the ones that they do actually in the homework, they're pretty straightforward. And a lot of them are like the 10s and stuff like that. So it's not going to have that little bit of an issue. If it does and it comes up to be something wrong, just let me know and I'll figure out why. Yes,
So when you say round to the nearest number, you mean like
round correctly.
Okay.
Yeah, so 5 or above, you round up.
Yeah.
Under 5, you round down. Yeah, round correctly. Also a good question because sometimes it is just trim off the number and you take, so yes. All right, so that's mean. Now let's look at median. So median is the actual center of all the data points. And you'd think, okay, finding the center should not be difficult. However, I have learned that's not always the case. The very first thing you have to do before you can find the median, all the numbers have to be in order. Okay? You have to have the numbers in order to find the middle number. I didn't say that one semester, and I was walking around looking, and there was a whole bunch of people that just didn't put the numbers in order, just calculating in the middle. I'm like, why are we getting all these different numbers? And that was why. So yes, all the numbers have to be in order first. The next way, honestly, is totally up to you. Yes.
If it's a even set of numbers.
We're going to talk about that one second. So the next way to do this is actually up to you. Like some ways people will just, you count up how many you have and then cut that in half and you say, okay, I'm going to count it from each side. Some people will just cross off the numbers on each side. Whatever method you want to do to find that middle number or to find the 2 middle numbers in case it's actually even, which we're going to talk about in a second, is fine. All right. So when we're looking at the number, if the data set is odd, if I have an odd number of them, you will only have 1 number left in the middle. Okay. If it is even, we're going to have 2 numbers in the middle. So you can't have 2 numbers in the middle. We need to find the number in the middle of those 2 numbers, which means we find the average of those 2 numbers or the mean. So let's look at this. So this one, we've got how many numbers? 10. All right. Are they in order? No. Put them in order. All right, they're all in order now. Yes. Oh, gotcha. Now, I want to find the middle numbers, right? So and we're left with two numbers in the middle. We have to add them up and divide by 2. What's 83 plus 85 divided by 2? 84. So my median is 84 for this one. What's the mean?
Of this data set?
Yeah.
Oh,
Yeah.
$83.
Okay. I didn't do it, so I'm gonna.
I agree.
Okay, good. So either one of those, both represent the data pretty well, right? So, okay. All right. So that's when we have 10 numbers. So in this case, we have 11 numbers. So find the median of these numbers. In order. So my median is 3. Okay, that makes sense? Good. Because that's all median is. All right, last one, mode. Well, last one of these. Mode is the one that appears most often. So in this problem, what is the mode? How many times does 0 appear?
3. I was trying to see if there's another one.
3. Is there any others? The ones that appear 3 times? Okay, so in this problem, my mode is 0. Because that's the one that appears most often. What's the mode of this one?
0 and 1.
Yes. So mode is actually the only one that can actually have multiple answers. Was there 3? Oh yeah, there was actually 3 there. I didn't notice the 3 was there twice. So yeah, it would be actually 0, 1, and 3 in this case. I missed the 3 was there twice. So you can have multiple modes. Okay. So for this one, we have 0, 1, and 3. So if every single number appeared twice except for one of them, all those would be the mode except for the one that appeared once. Okay. If every number appeared twice, none of them are a mode. Okay. It has to appear more times than something else. All right. So if for mode, we can have no mode. If every number appeared once, we have no mode. You can have one mode, or we can have multiple modes, depending on what it is. Mode is also the only other one that works with quantity or qualitative data, because it doesn't necessarily have to be a numerical thing, because we're just literally counting the one that appeared most often. Okay. Good. All right. Yes.
The mean, median, and mode are all measures of location, right?
Yes. They're known as measures of central tendency. So measures of central tendency are the ones that are telling you about where the middles are, or what's going on the majority of the time. I think that's yeah. We'll talk about where that goes in a second. I was like, I'm pretty sure that was my next slide. All right, so we talked a little bit about outliers. So an outlier is a data that's extremely different from the other ones. Not every outlier has to be on the high end. You can have outliers on the lower end too. So if you're thinking about like your grades and you did really, really well on all your tests, but you skipped one and you got a 0 on it. That 0 could be an outlier. Right? It's not representative of typically what you do. Next class, next Wednesday, I will show you, we will actually figure out how to calculate if it's an outlier. There's actually a specific calculation to determine that. It's not just any number that's too big or too small. So, because otherwise we'd be eliminating data that we might have to use. The little tables underneath it. So we'll look at the one on the right first. So sensitivity outliers. The only one that's really sensitive to outliers is median. Is mean. Not median. Is mean. Because that's the one that gets pulled by the outlier. Median and mode, no. The outliers have no impact on them. If the outlier is the mode, that one appeared most often, you're going to use it because it's no longer an outlier. The trimmed mean takes care of my outliers by eliminating. The table on the left shows you which type of data that you can use to do those calculations. Notice how everything works for quantitative. For qualitative, mode works. And median, you can use if you can put the information in order. Okay, so if there's some kind of an order to it, if it's ordinal, I can use a median because that's just trying to find the middle. Okay, but you have to be able to put them in order. So like if I wanted to find the middle month, I could do that. There would actually be 2, but I could do that. Okay. Any questions with those? All right. Let's look at what measures of central tendency show me. You're going to see this graph in your sleep by the end of this class. We're going to do so much stuff with this bell curve, it's not even funny. So if it's a true and perfect bell curve, your mean, your median, and your mode are all right in the center. It's your mode because it's the peak. That would be the one that appears most often. If it's perfectly symmetrical on both sides, your median is going to be there in the middle because there's the exact same number on both sides. If the numbers are symmetrical in a way that they balance each other out, your mean will also be right in the middle. So a uniform curve or a bell curve will have your mean, median, and mode all right in the center. Now, we all know that data does not always work perfectly. So that is not always going to be the case. However, we do a lot of stuff to make that the case. Because then I can just focus on using mean and I don't have to worry about medians and stuff like that. Because mean we can calculate, it's a lot easier to deal with than median and mode. All right, remember these from last class? The skewing. And we're like, why is it the opposite way you would think about it? So positively skewed and negatively skewed. Or when we were looking at it in the last class, it was, what was it, left and right, right? So notice how this is being pulled this way. So your mean is being pulled to the positive side or the right side. That's why it's known as a right skew or positively skewed. That means these values over here are what's pulling that mean that direction. Same concept here. That mean is being pulled to the left of the peak by these values over here. Okay. It's known as positively and negatively because if you look at a graph, positives on the right side of the graph, negatives on the left side of the graph. And if we look at that bell curve, you'll notice that these are the positive numbers, these are the negative numbers. So that's why we were talking about right skewed and left skewed. That's why it was opposite of the way that you would typically think about it. It's not looking where the peak is. It's looking at where that mean is being pulled to it. So if it's you have really high outliers, it's pulling it to the right. It's pulling it positive. If you have really low outliers, it's pulling it to the left or the negative side. That make sense? Awesome. All right. So next. How can we tell? So if we could have two sets of data that would have the exact same mean, median, and mode, but the numbers won't be the same. We'd still have to be able to have some way to be able to determine which one we want, how the data is. So the next way that we look at it, so we talked about measures of central tendency. Now we want to talk about deviation or dispersion or spread. So we want to talk about how we could figure out how far something is spread from the mean. Now remember, when we're looking at in terms of that bell curve, mean, median, and mode is all basically the same thing. And the vast majority of the calculations that we're going to be going forward, we're going to be looking at it in terms of that bell curve. So we're going to assume that those would all be giving you the exact same information anyway. So we always look at deviation from the mean for these calculations. So the first thing we would do is we could subtract them. Okay. So my mean in this case is 10. I subtract them, I get -7, 2, 10, 5, and -10. Question is, okay, great. What do I do with that? Like, how is that helpful to me? Yes.
Does it stay negative or is it?
Well, that would be the question. Like, how is that helpful? Like, first of all, we had a bunch of numbers here. We don't have one number. So when we first start looking at doing the like deviations from the mean, we still have to do something with those numbers. All right. And there's a few different ways we actually do that. There's a few different methods that we can use. One is actually known as mean absolute deviation, because what does absolute value do? What does absolute value do? Anybody remember? Those are those two bars on either side of the numbers. It basically is taking away the negative sign. So absolute value tells you distance from 0. That's one way we can get rid of a negative sign. The other way we can do it is actually squaring the numbers. If you multiply a number by itself, it'll always be positive. Because -7 times -7 is positive 49. The negative times the negative is a positive. So we can square them. Each of those methods are okay, and we still have to do some other stuff with it. We're going to talk about those methods in a second. Well, we're going to talk about the big method in a second. All right, one last thing before we actually get into the more complicated thing. Range, really simple. Highest, lowest number, just subtract it. So in this case, what's the range for this set of numbers? Yeah, 24 minus 1. Highest number, lowest number, just subtract it. That's a really quick and easy way to tell you how something's spread, right? However, if I was to multiply all those numbers by 10, my spread would now be 230, right? So the question is okay, like, how can we compare those numbers? Like, when we're talking spread, we're just looking at the highest and lowest number for the range. That's one way to do it. But depending on the actual numbers that I have, depends on how that's going to be looked at and how we can interpret that information. So range is a very blunt knife approach on it. Works, but it's not that great. The method that we're going to use is known as standard deviation. So there's two different well, just because of the way Hawks does it. We're going to look at, so you have variance first, and then the standard deviation is just the square root of the variance. I am not going to have you calculate this out by yourself. I just have to get the website. Give me 1 second.
Square root
Of the variance, which I will tell you in a second. I'm just getting the website. What that there? Really? Okay, it's not there. All right, hold on. I'm just trying to get the calculator that we're going to use. Okay. So let's actually go through. Remember, symbols are important. This little squiggly symbol, it's another Greek letter. That symbol means standard deviation. It's not a 6. Let me make it a little better. So that symbol means standard deviation. That symbol squared means variance. And when you're talking about a population, your mean is that U symbol. Again, the symbols aren't as important as what they mean. However, you're going to see these symbols, so knowing what they mean is very important. Okay. The difference between the top and the bottom is for population, the bottom is for sample. Notice we have that X bar that we talked about before as our mean. That's when we're looking at samples. For samples, S is my standard deviation and S squared is my variance. So for population, we like the Greek letters, and for samples, we use our regular lettering. All right. Everybody got that down? You're not going to need the formulas. Okay. I'm going to give you a calculator to do it. You will not need the formulas. I'm going to show you what it does, though. All right. So here is 6 people running a 1,000-meter course. It took them 5 minutes, 10 minutes, 9 minutes, 11 minutes, 9 minutes, and 7 minutes. If we wanted to figure out the variance and then the standard deviation of that variance, the first step we have to do is we would find, again, you're not going to have to do this. So don't sit there and write everything on the board down. You're never going to have to do this. I want to explain this so when the number you get at the end kind of makes sense. First thing we do is we're going to subtract from the mean. We're looking at the deviation. Okay? And she asked at the beginning, well, what do we do with the negative numbers? Okay? And I said there's options, right? We can either do the square root, or we can do the square, or we can do absolute value. Standard deviation uses the squares. So we take each of those deviations and we square them. And then we add them all up. And then we divide by how many we had. Since it's a sample, we divide by the number we have minus 1. So we're going to divide by 5. Why would we subtract 1 from the total when we're doing a sample? Is a sample the actual population? Is that the same thing? No, sample's a smaller piece, right? Because we're using a smaller piece, it is a little less accurate. So they use that by minusing 1 to take that piece off. So my variance for this is 4.7. My standard deviation is the square root of 4.7, which is, hold on. I do not know this off the top of my head.
Or 160.
I'm just going to round 1 decimal place, so door 2. Go 1 7. So 2.17. So that, what that's telling me is it's telling me how spread my information is. Okay. So what's the mean of this? The mean was 8.5, right? I went way down. There we go. What's the mean of those numbers? Yeah. Yeah. It's still 8.5, right? So if I did the same thing I just did a minute ago, well, with their calculation. So I did 7 minus 8.5, 8 minus 8.5, 8 minus 8.5, 9 minus 8.5, and I would get 1.5, 8.5, 0.5, 0.5, and 1.5. So 2.25 by squaring them. Add those all up. And we get 5.5, and I'm dividing it by 5, so I get 1.1. That's my variance. Again, you're not going to have to do this. And then my square root, if I take the square root of that, and that's my standard deviation. So two sets of numbers with the exact same mean have two different variances and two different standard deviations, right? If you looked at these numbers compared to the numbers on this one, what's the biggest difference between these sets of numbers? That one goes from 7 to 10, right? And this one goes from what? 5 to 11. These numbers are more spread out. That's why your standard deviation's higher, because your numbers are more spread out. The more consistent the numbers are, the closer the numbers are together, the smaller your standard deviation is going to be. Okay, so standard deviation is telling you how spread that information is. If all of them are the exact same number, what would my standard deviation be? Right. Because that would be my mean, right? And I would subtract them from the mean, I get a bunch of zeros. So if every number was the exact same, I'd have a standard deviation of 0. Okay, so standard deviation is telling me how spread that information is, and we can use that to start comparing things. So standard deviation, this is the definition, and then I will show you the wonderful calculator that we're going to use. And we will do a problem with that wonderful calculator. So standard deviation tells me how much of the data varies. So we just talked about. Standard deviation is always a non-negative number. It can never be negative. Okay, it is always going to be a positive number because we squared the numbers to get rid of that thing. So it'll always be a positive number. As we said, if all the numbers are the same, it would be 0. The standard deviation can get really big when you have some outliers in the data. So, because if you think about it, if I go back to this set of numbers here, if I added a number of 500 on the end here, and I had to do 500 minus 8.5, that's going to give me a really, really big number over here, right? Which is going to make that variance really high, and then the square root is going to be high. So that one number can really throw out that standard deviation. So one little number in that can make it dramatically bigger. You also want to keep them in the same unit. So like that problem we were just talking about, my standard deviation is 2.17 minutes because we were talking about minutes in that respect. All right. I just need a data set real quick. So I can show you the next thing. All right. What we're going to use so I will have this link to my website for this class, so it'll be on the notes. The website's called calculator.net. There's a whole bunch of calculators on that. The one that we're going to be concerned with is known as the standard deviation calculator. So if you go to calculator.net, it's right under math calculators. The very last one, standard deviation. The nice thing about this is all you have to do is type in your numbers. So we don't have to actually write or do all those calculations. We can just type in the numbers into this calculator.
So I assume you don't have to order them.
You do not have to order them. The only thing that matters is you have to tell it if it's a population or a sample. That matters. Okay? So, based on the question they ask you, you'll know if it's either going to be a sample or if it's going to be a population of information. All right, so we're going to say this one's a sample. I typed the numbers in. Oh, I forgot I have to put commas between them. You have to put commas between them. In Hawks, there should be a button typically next to the data that lets you copy it, and then you can paste it in this box. And then it gives me my answer. Okay. You can do the same thing in Google Docs. You can use the same thing in Excel. They all have it built in. Okay. So this is not something that, oh my God, he's giving me this cheap thing. Every person in the world is never doing out standard deviation by hand. First of all, if you looked at when I just did it for 6 numbers, how much work it took to do it, imagine doing it for 100 numbers. No way. So everybody uses a calculator to do this stuff. So that's why I'm showing you how to use the calculator. So this will give you your standard deviation. It will give you your variance. So you don't need to worry about a different calculator. So if Hawks is asking you for variance, you pick the variance one. If Hawks is asking you for standard deviation, use the standard deviation. The key piece, though, is, again, remembering if it's a population or a sample, because this is the sample deviation, where if I did the same thing with a population, it is a different number. Okay? Because sample, I'm doing n-1 on the bottom, standard deviation or population, I am not. I'm just doing the n. So it will change your answer. Yes. Yes. So you can do this. So your test is all going to be at Hawks. So the day of the test, you have one of 2 options. You can bring your own computer, or you can use all the computers in front of you. Okay? I will have this linked up on my website already, so you can literally just go to my website, click on the link, and pull it up as an extra tab on your thing for the test. Yep. Yep. Because again, there's no point in me making you do it all out by hand when you are never, ever going to do it. I know teachers who do make you do this completely out by hand or typing it out into the calculator to get the answer. It's a nightmare, and it's so simple to make a mistake and get the wrong answer. It's just not worth it. So that is literally how easy it is to find standard deviation. Okay. What does standard deviation mean?
How far the data varies.
It is the spread, how much it varies. Okay. Okay. Actually put this in here. I did have the actual data, so this way you can easily see it afterwards. All right, last thing. One more thing because it's in Hawks. Coefficient of variation. So when we're looking at data and we want to be able to compare different sets of information, we need to have some way to be able to compare 2 sets of data. Because like I said, if I had multiplied all those by 10, the variance is still going to be a lot higher. Your standard deviation will be a lot higher. But the question is it way higher than something else? But we don't know. So we have to do, there's something known as a coefficient of variation. All it takes is your standard deviation divided by your mean. Okay? Standard deviation divided by mean. And then you multiply it by 100 to get that as a percent. All right? So standard deviation divided by the mean. That's all you're doing for the coefficient of variance. The reason for that is like this problem. So we want to compare 2 brands of vitamins to see if they are consistent, or we want to figure out which brand is more consistent. So brand A has got 500 milligrams in it, or claims to have 500 milligrams in it. Brand B claims to have 250 milligrams in it. So the mean is 500, the mean is 250. The standard deviation for brand A is 10. The standard deviation for brand B is 7. Remember what I said standard deviation is how much variance is, right? So if we were just looking at the standard deviation, we would say brand B is more consistent. It's got a smaller standard deviation. However, the numbers are bigger in brand A. That's going to increase your standard deviation. That's where the coefficient of variance comes in. So we can compare these two. So to do that, all we do is take the standard deviation and divide it by the mean. So for brand A, I have 10 divided by 500. It is always going to give you a decimal. Okay? So if you forget and do it backwards and you get a big number, you did something wrong. Just flip it over. It'll always give you a decimal. It'll always be a number less than 1. All right, so what's 10 divided by 500?
0.45.
No. 0.2 if I remember right.
Yeah. I would do.
Which is 2%. You did it backwards and said, oh, I'm going to make this the number. Because that would be 5. It ends up being like 1/50th. All right, so that's A. Let's look at B. So we did same thing. 7 over 250. You did it backwards.
Oh, right.
Remember, it's always got to be a decimal. If you get a number bigger than 1, you made a mistake. Flip it over.
Sorry. Oh,
Which is 2.8%. So which one's more consistent? Brand A. That's where the coefficient of variance comes in. It allows us to be able to compare our means and our standard deviations to determine out which one's going to be more consistent overall. Okay? Yes.
Is standard deviation and standards of deviation the same thing?
Yes.
Okay, I wasn't sure.
Yeah, you'll always hear it say standard deviation.
Okay, I've heard it.
Yeah, it'll always be written as standard deviation. If somebody puts standard of deviation, I can't imagine a math teacher had said that. That's because I guarantee that was an English person going, no, that just doesn't make sense. There has to be an of somewhere in there. Yeah, it's just standard deviation. All right. Questions? Yes.
Did you say A is the more consistent one?
Yep, because it's, the percent's lower. You want the lower the percentage, the closer, that's the more consistent it's going to be. And if we think about it, remember, what's the standard deviation of if perfect consistency would be what standard deviation? 0. So 0 divided by 500 would be a 0%. And that'd be perfect consistency, right? So that goes back to that concept. The lower the standard deviation, the more consistent it is, and in that case would bring down that percent there for the coefficient of variance and make it more consistent. All right, remember, no class on Monday. Monday's President's Day, the school's closed. It's not just my class, it's all classes. I will see you on Wednesday. And I realized they didn't post the videos for chapter 3. I posted them today. They're both up there, and both notes are up there. So, yeah, I realized that this morning. I'm like,